Hello, everyone. Thank you for joining us this afternoon. My name is Brad Schmidt, and I'll be your host for this webinar. So today's topic is part of a series that we have done during the AUVSI conference. This particular topic is on GNSS augmentation solutions for UAV surveying and mapping. So we're going to walk you through the variety of different solutions that Applanix has for correcting UAV data with an augmentation system, i.e. to get your accuracy down from maybe a meter or so down to a couple of centimeters. So that's what we'll be doing today. Let's see, everybody, I just want to mention a few basic logistical things. Everyone is on mute. If you have any problems, my colleague Cynthia is online. You can simply communicate her within the question or the chat box, and she'll try to resolve any problems you may have if you're unable to see or hear the presentation. This particular presentation is one of 5 that we're doing over the course of the AUVSI conference, and basically addressing different topics that we have that are relevant to our portfolio that supports direct georeferencing, i.e. direct georeferencing for UAV surveying and mapping in particular. And so this particular presentation is on augmentation solutions, which is a critical part of that. Now, at the end of the presentation, we will take questions. We'll basically come on and basically take any questions that you may have after seeing the presentation. And certainly if you have those questions, if you can type them in as we go through, and we'll just kind of keep track of those questions and then open it up at the end to handle questions. Also, if there's something of interest that you see at the end of the presentation that you would like to meet with us one-on-one to discuss further, you can go to our website, Applanix.com. We actually have a sign-up sheet there where we'll basically take an appointment and be happy to kind of discuss any kind of requirements or needs that you may have. Just one last thing before we get started with the presentation. We have recorded we have recorded the actual information part of this presentation. So my colleague Kurt will be presenting along with myself. So you'll see that as we go through the next half hour. And as I say, at the other end, we'll basically, once we finish the presentation, we'll open it up to questions and we'll go from there. And yeah, well, I think that that basically covers everything I needed to say right now. So Cynthia, if you could basically just start the presentation, I'd appreciate that.
Yeah, just one moment.
Brad Schmidt, I'll be your host for today, and I'm a global UAV sales manager. And I'm joined today by Kurt Bialetti, who is our product support analyst, and Kurt's going to be helping me with some of the technical portion of the presentation. So we'll slowly get into things. Our format for today is a 20-minute presentation with about 10 minutes for Q&A. Now, you can enter your questions, any questions you may have, into the chat box, and at the end of the presentation, we'll go through and take all of those questions and hopefully get you some answers. And finally, we will be making a recording of this, and we will be publishing that recording. So don't fear if you don't get everything in the webinar today. You'll be able to go back and kind of review the material at a later time. Our agenda for today is we'll talk a little bit about who we are for those who may be joining for the first time. We'll give you a bit of a background into who Applanix is. And then we're going to get right into it, right into the augmentation solution. So we're going to talk about physical base stations. We're going to talk about using virtual reference stations. And we're also going to talk about something that Trimble has set up globally called Trimble PPRTX, which again is a non-physical, or there's no physical base station involved in using PPRTX. And we're going to talk about what that is and how that works and why you might want to use it. And we're also going to take a look then at the data processing solutions. Obviously, you're collecting data on your UAV platform. You're capturing your GNSS or positional data with your GNSS and your integrated IMU on your UAV platform. The IMU captures the orientation data. You take that along with your correction information. You process that through a piece of software, which Kurt's going to talk about later on, and you get your final products coming out of that, either an EO file, exterior orientation file, or we can actually generate a LAS file as well, which can then be used in other applications. So let's just turn right now to Applanix a little bit, and a little bit about the company. So Applanix was formed as a spin-off from Honeywell in 1991. We're basically specialist in inertial navigation systems and integrating that technology with GNSS, which actually made for the marriage with Trimble in 2003. We were acquired by Trimble in 2003. So Trimble is a leader in GNSS technology. Applanix is a leader in INS, or inertial navigation system technology. Integrating that technology then for the purposes of direct georeferencing is really what we're all about. And a lot of the technology we're going to talk about today, or at least the supporting technology on the GNSS IMU side, has been well proven in our manned aerial products over many, many years. These products were just refactored for the UAV industry, specifically to support the surveying and mapping aspects of the UAV industry. So, we're not into videography or anything like that. We are specifically into surveying and mapping and precision positioning of data on the ground. Just a little bit more about Applanix. We do have a land division that where we have mobile mapping solutions and autonomy solutions. We have a marine mapping division, as well as our airborne division, which is composed of our manned airborne segment and an unmanned segment.
Done. So yeah, going into diving right directly into things, when we start to try to talk about direct georeferencing and how we can get an optimal solution from that, we need to really start talking about GNSS augmentation and what that really means from a mapping and survey application here. So the GNSS augmentation is utilizing additional measurements, whether they be from independent ground-based measurements from a dedicated base station or corrections from certain modeling to minimize and characterize the errors in the GNSS observations. This is going to be critical to get those real-world positioning down to that centimeter level as talked about. And then we can apply our direct georeferencing from there, produce final products. So some of the ways that we typically utilize this, as previously mentioned, are single base station, whether this be from a dedicated base station that you put up or a CORS network. This is a very common and widely accepted and utilized method utilizing differential GNSS. Now, we are also going to talk about really quickly the post-processing VRS using Applanix SmartBase, and then finally wrap up with post-processed Centerpoint RTX, which is kind of Trimble's new proprietary corrections there. So going directly into this, with the single base stations, what we're really trying to do is apply that differential GNSS, which is a very common GNSS surveying technique, where we're going to be utilizing a survey grade high accuracy, multi-frequency, multi-constellational reference station to apply a differential GNSS and completely remove a lot of the common errors that are associated with GNSS observations. This is typically done either using a dedicated receiver placed on each mission or a continuously operating reference station, such as a CORS downloaded from the web, or even a base station provided from a network provider such as CanNet or SmartNet or something similar to that. Going a little bit more into how this is actually physically working. If you are setting up your own base station, you're going to be setting up again, a survey grade reference station in your project or near your project area. You're going to want to be collecting at least that 30 minutes of survey data so that you can start to get a really accurate post-processed coordinate for that setup base station if it is not set up over its own ground control point or set up as a core station. And then you're going to need to have that proper overlap between the rover and the base station to get a proper differential GNSS correction applied. So going into a little bit more about how Applanix has introduced this, I'm going to talk a little bit about Smart Target, which is the next slide. When it comes through, here we go. Smart Target, which is what Trimble has introduced to kind of address this, provides both a survey grade GNSS receiver along with a target that you can be placed into your project area. You can then correct your GNSS observations with this and then utilize this as a quality control point. The coordinates can be automatically surveyed through POSPAC utilizing the RTX base station survey, and provides a really nice tie-in for everything and makes it a very versatile tool to be utilized in the field. Alternatively, commonly used are the core stations. These are going to be your continuously operating reference stations that are found throughout the world. Here you have to be a little bit more careful making sure that the network or your project area is close to one of these, ideally within the 30-kilometer baseline length. Additionally, another limitation that's commonly applied is that we have to wait 24 hours as we look for the 24-hour RINEX file provided from these core stations. So it does have some limitations, but then you don't need to properly set up your own base station, and it provides you again, those really good accuracies. So this is going to be perfect for your small area locations and your mapping projects that you're not doing such things as corridor mapping. You are going to be limited in your baseline length, so you need to plan ahead and make sure that everything is collected properly. But in doing so, you can obtain those centimeter accuracy levels. All in all, it does really well, and it is very commonly used in UAV applications. So talking next about a VRS, which is trying to eliminate some of the limitations that are found with single base processing. There's two Applanix smart bases that I'm going to talk about really quick. There is a full version, which is through POSPAC, which will have functionality for creating a rover or like a virtual reference station that moves with the rover, trying to minimize that baseline length, opposed to an online version. That has limited functionality where it creates a static virtual reference station close to your project area. But both are very, very acceptable and utilized quite commonly in UAV applications where we can start to try to minimize those baseline lengths based on a network of stations. So we're utilizing this network of stations to create a virtual reference station. This is typically can be really nicely done either with your core stations, or if you have any private companies that you subscribe to, and you can supplement those. Additionally, kind of going on to that, talking a little bit about exactly how it works, we're utilizing Trimble's VRS technology to take that network of stations and obtain a fixed ambiguity solution. Typically, this is done by generating spatially ionospheric models and correcting for geometric errors for both the base and the rover location. This will provide a very nice optimal VRS that follows the rover and can then, again, minimize those baseline lengths. So this is going to be really great for your larger areas or your corridor mapping, because you get that centimeter level accuracy without that baseline length dependency, because the baseline length is following along with the rover. Limitations mainly being that you need to make sure that your area has proper coverage, aka the base stations surround your area so that we can do proper interpolation techniques, and that you must wait 24 hours for the base stations to become available, typically 24 hours. Again, now trying to address those types of limitations, Trimble has really been focusing a lot of research and development into their Centerport RTX technology. So this is a little bit of about what RTX is. So this is going to be your global real-time GNSS correction technology that Trimble has created. This is going to be using their dedicated network stations throughout the world to create that track most of the constellations, including GPS, GLONASS, Beidou, QZSS, and Galileo. And then utilizing this information, we can start to create, essentially compute precise ephemeris information in near real time. Again, this will also start to talk about and correct for the atmospheric delay models. It is certified with a integrity layer just to ensure correctness and ensure safety for applications such as automotive with the self-driving vehicles. The great part of it is there's no need for setting up your dedicated base stations yourself, and it is the accuracy is approaching what you can obtain from an RTK solution. Now, since this isn't utilizing directly differential GNSS, so we don't immediately eliminate the errors, we have to model these errors. So this takes some convergence times that you have to start to look at, and that's all based on what models are being utilized, so what ionospheric models. So if you're in a region that has standard ionospheric models, then typically our convergence times are around 15 minutes before we're going to get full accuracy. And then if you're in a fast convergence region where we have a regional ionospheric model, opposed to just the global one, we're going to get about a 5 or less than 5 minutes of a convergence time. Now, here's just a quick plot to show examples here. The little blue dots are going to be the GNSS observations, and you'll see in the left example where we're utilizing the global model. At the beginning, the dots are all over the place. We got our green line, which is indicating the mean, and it looks like it's getting under the 5 centimeter mark at roughly 4.7 minutes. We got our confidence level at 68%, which is going to be the pink line. Again, it is going under the 5 centimeter level at 3.4 minutes. Then looking at the confidence level of 90, again, that's hitting at 6 minutes, and then by 6.6 minutes, we have a 95% confidence interval that it's under the 5 centimeter error. Now, and that's specifically for horizontal performance. Now, looking at a RTX fast region where we're utilizing a denser network of stations to get a very region-specific model, we can see that everything's converging extremely fast with the mean and both the 68 and the 90% confidence interval converging at the 0.7 minutes, and then finally at the 95 confidence interval at the 8-minute interval. Start talking a little bit about where these regions are fast. You'll see that a lot of North America is starting to get covered here, with all of the states completely covered, bleeding up into Canada and the high populated areas such as Toronto and into Quebec, and then over through some of the prairie provinces. Starting to get really good coverage here, and it is constantly expanding the network. Now, if you start looking at Europe, you'll see that they have a very dense, all of Europe's covered, plus we're starting to bleed into some additional countries with that RTX fast regions. So when you start post-processing utilizing RTX, which we're going to just abbreviate down to PPRTX, and both in POSPAC or POSPAC UAV. The workflow is pretty straightforward and simple. You get your trajectory information, you upload it to the RTX servers. The RTX servers then determine the corrections for that area, provide those corrections back to you, which we then feed into the GNSS processor along with the raw observables, so we can really correct that GNSS data. And then all this information is fed into the inertial processor to blend in with the IMU and provide that highly accurate position and orientation information. Going from there, again, basic uses here, we're looking at large areas or quarter mapping because you're not worried about a baseline length, you're not worried about too much there, and it's really good for remote areas where there is very minimal baseline or base stations, such as a lot of places in northern Canada or even just throughout the US. Gets you that centimeter level accuracy without needing to worry about where you're flying or where you're located. Main limitation though here being the convergence times. Because we're trying to ensure convergence times in both a forward and a reverse direction, the entire project must be longer than the convergence time. So for instance, 30 minutes, because there's a 15 minutes convergence time in the forward direction and a 15-minute convergence time in the backwards direction, we're going to want a 30-minute convergence time in standard regions so that we can get a convergence-free zone for the entire collection. This isn't too bad, but it's something you need to keep in mind. In fast regions, you just need that 10 minutes of the flight completely in 10 minutes. Now in a UAV application, it's very common for these to get these times without burning battery power. You can do some static on the ground using a additional power source and then take off. Going a little bit now talking about post-processing with POSPAC UAV. So POSPAC UAVs are a post-processing suite that's been designed and tailored directly for UAV applications. You're going to be feeding in your raw data, specifically GNSS, inertial, or additional sensor data such as a DMI, and then whatever base station data if you are doing something such as a VRS network or a dedicated base station. And then we can go ahead and apply our common filter and our forward, reverse, and smoothing to obtain a smooth best estimate of trajectory. This is something that's very commonly used for LiDAR applications. Additionally, as another additional input, we can also take in the raw LiDAR data and start to adjust the trajectory and output a LAS file. So additionally, looking from a camera perspective, exterior orientation parameters and exterior orientation are extremely important just so you can start to apply that direct georeferencing. So again, that's a very common output that POSPAC can start to play with. Nice and modular also, so in the case that you need to make a custom export for whatever application that you require, specifically referring to the position and orientation information, it's more than happy to do so. Main benefits over something like AT with ground control stations to provide that precise mapping and survey grade solution. In POSPAC, you get to really save time because you're going to be applying that direct georeferencing. You can also start to really dive into the data and understand what's happening and where any errors are coming from, and try to really find out where your optimal sources are. We are also going to talk a little bit real quickly about something relatively new here, which is the UAV cloud. POSPAC UAV cloud is something that we've just introduced, where POSPAC will apply or provide an API for OEM users to build into their own software. This can be built on a pay-as-you-go type plan where the hardware has become a little bit cheaper so that you can pay as you get your projects in. And when you get a project in, you go ahead and upload the data. It post-processes in the cloud, provides you your end results, and then you can go ahead and supplement in that regard. Now, again, it provides an alternative licensing option as opposed to just paying a large amount upfront to have the post-processing software in full functionality by giving that different options to the users.
Okay, thanks very much, Kurt. And certainly, if you have questions regarding Kurt's presentation, just enter them into the chat box, and then we'll address them in just a moment or two. Wrap things up here before we move on to questions. So we did take a look today at augmentation systems or augmentation solutions for survey and mapping missions, and we took a look at 3 different solutions that are available: single base station, virtual reference station working with CORS network, as well as the POSPAC PPRTX solution from Trimble. And then we also had a look at our post-processing software, which is called POSPAC UAV. We also do have another post-processing solution called POSPAC MMS, but that basically supports processing from all of our suite of products, right from the marine suite to land and autonomy and mobility as well as all of the aerial processing products that we provide. Okay. So if you have any questions, please enter them in the, I guess the chat window, or it may say questions on your screen. You can feel free to enter them there, and we will answer any questions you have. Cynthia, do you see any questions on your end?
Yep, I see one question here. It says, where can I buy or order Smart Base in Germany?
In German?
In Germany, yeah.
Oh, in Germany, okay. Yeah, no problem. So basically, we have a representative for our European region. His name is Jesus Riez, and his contact details are actually on our website. We've got a list of all of our sales contacts on the website. So basically, I would just encourage you to, well, do two things. You can either send a request to sales@applanix.com, and Jesus will pick that up, or at least one of us will follow up with you so that we can get you the information and the pricing for that, and we'll go from there.
Hi, Brad. Just additional question. The Smart Base, it's simple to order within a post pack, but in Europe it's really country based. So I'm not sure if Germany has the free core stations. So you might need subscription to the core stations as well, to the German stations there, in order for post pack to have access to download it.
Okay, yeah, good point, Surgeon. So yeah, we can certainly check on that for you and see if the coverage is there. So the Smart Base will actually work when you actually buy it.
You can check as well at our website. We have in a cloud free version on Applanix.com, so you can check entire coverage for entire world where it's available, the VRS network.
Okay, great. Thanks for that clarification, Surgeon. Is there any other questions you see coming in, Cynthia?
Not yet.
Okay. So hopefully just we'll wait a minute or two longer in case there are any other questions, but I'll just kind of start my my wrap up in the meantime. So certainly if you're looking for more information about what you've heard today, you can find that on our website. If you go to applanix.com, www.applanix.com, and you go to our UAV pages, you'll see all of this information that we've talked to there. You'll be able to go through that. Also, I do want to point out that on our website, we do have a webinar center. If you go to that under news and blogs, you'll actually see a variety of webinars, including this one, including the recording for this one. So if you want to review it later on to get more information, or if you want to take a look at some of the other products that we have, you'll find that information there as well too. And I guess that's about it. I just want to maybe put a plug in for our last session tomorrow. We're doing one more at 10:30 Eastern time tomorrow on POSPAC UAV. We'll basically take you through what POSPAC UAV is, how to process the data collected from these augmentation solutions, and from the DG capabilities that you have on board your UAV to be able to directly georeference your data. We're going to walk through that in detail. You'll see both an explanation and with the features on what POSPAC has to offer, as well as we'll be doing a bit of a demonstration of the software as well too. So that's tomorrow at 10:30 Eastern, and you can sign up for that on our website. So just want to see if there's anything, any more questions before we sign off. Cynthia, anything further? Yep.
Yeah, one more question. They're asking, is there any accuracy difference in single base, Smart Base, or PPRTX results?
Surgeon?
Well, you can look at the data sheet. So basically, the single base is 2 to 5 centimeters on trajectory, same as Smart Base with a good. The single base within a baseline of 20 kilometers it's around 2 to 5 centimeters. So smart base with a good smart base network coverage, like where you have the main station 75 kilometers and the rest of the stations like around the project area, delivers the same performance as the smart base, just of course for the bigger areas that you fly. And PPRTX at the moment is a little bit worse, especially in vertical. So what we are seeing is around 6 centimeters, something like this, and 6-7 centimeters, and most of that is constant bias. So the PPRTX, I would say it's 3 to 6, 4 to 6 centimeters. So.
Is there any difference, Surgeon, between the PPRTX and the fast regions with respect to accuracy versus the global?
No, there is no difference within a fast region and standard region once the solution converges. So
okay.
So once the solution converges, so it's basically the same accuracy, 3 to 6 centimeters.
Mm-hmm. Okay.
The only difference is time to converge to that accuracy.
Yeah. So if you don't have a base station and you're in an area where you don't have any cores, you can still fly your UAV missions and get survey grade accuracy with using the PPRTX software or approach, RTX.
Yes, definitely.
Yeah, great. Okay. Any further questions, Cynthia?
I think that's it.
Okay, well, thank you very much. And certainly if you do have questions, you can get those to us, because I know after sometimes you kind of leave a webinar like this, you kind of think, oh, I wish I would have asked that, or wish I would have asked that. But if you do think of those questions, we are available at the AUVSI conference under the Applanix booth. Just drop by, you can feed us your questions there, or certainly you can go to our website and we have some ways of interfacing with our sales and our support team there to get any answers that you may want. And on that note, we'll wrap it up for today. And hopefully, if you're interested in learning more about the POSPAC UAV software, we'll see you tomorrow morning at 10:30 Eastern. Once again, thank you very much. Thank you, Cynthia. Thank you, Surgeon, for joining us this afternoon and supporting us. And we'll see you all again soon. Bye-bye.